Hello, Professor. Good morning. Today we are going to present a project on dynamic lightweight authentication for IoT and time-sensitive application presented by Srujana. And
Hi, Professor. This is Bindusri.
In dynamic presentation, we are using IoT. In IoT, the four components, those are IoT devices, device coordinator, cloud node, and user. In IoT devices like healthcare, education, smart grid, these gadgets are used for the plenty of data, and the coordinator is used to connect between the node and the IoT devices. In cloud node, it generates the information, and as usual, users are who wants to use the information from the IoT application.
Coming to the protocol proposed, here we proposed a simple authentication mechanism that is light edge. It primarily consists of three components, which are devices, trust centers, and cloud servers. Every device is provided a special identification and passcode. Every server also has its unique identification. After authentication, the trusted center uses the defined cryptographic method to encrypt a message for the communication between the devices and cloud servers. Here we specify response time and latency thresholds in the trust center in order to safeguard the applications and authentication systems. We further assess every device dependability in order to establish their level of access. This is the sequence diagram of the proposed authentication protocol. It mainly has three components, IoT devices, trust center, and service provider.
In the first step,
here we have 12 steps, which we'll be discussing now.
Yeah, in the first step, every machine must be enrolled with the trust center for its data to be saved. In the second center, so every IoT device is assigned a unique identification by the TC.
Coming to the third step, in the third step, the device stores the user credentials in the database, and then it logs into the network with the given username and password. The next step, coming to the next step, the trust center authorizes the device's entry by reviewing the information stored in the database. Otherwise, it separates from the network. It disconnects from the network. In step 5, servers must also register with the trust center in order to service the IoT devices.
In the sixth step, the TC is provided each provider with a unique identification and password, and this is the CSP's data is recorded in the trust centers of database, and then TC gives the CSP a registration confirmation. And in the seventh step, the device sends a request to the provider after authenticating into the network.
In step 8, the device must be authenticated for each request to the cloud provider, as a result of which the server provides device data to the trust center, which then evaluates the device entry and grants a mutual key for connection. In step 9, the trust center delivers the keys to the cloud provider after validating the device verification in step 8. Coming to step 10, by exchanging the public keys between the provider and the device, the capacity to submit requests and receive services will be acquired here. In the next step, the device may now securely connect with the provider and request services using the provided key. In the final step, the device request would be responded to by the supplier.
Next part is simulation of results. In the simulation, results are given in the part of analyze the suggested protocol's performance in the light edge. Three techniques are compared to the suggested method. Here we can see the other three techniques, which is compared with the light edge. Uh, uh, in the next step, the protocol's validation was assured using Avispa software, and the calculation runtime price and the average communication cost were assessed using the MATLAB. Here we can see in the table 3 the attack resistance comparison, where here these are the method does not support the property, and these are the method supports the property. Here we can see the figure 2. Here we can see the figure 2. It despite the calculation time cost, including access the authentication time cost for various ways using a single device and a single cloud server. This light edge strategy, as indicated in the figure, outperforms the other option in terms of time cost. Here we can see this time cost with the different techniques. In the figure 3, we can see that compares the performance of the proposed solution in the previous ways under the several sorts of attacks, including evOps dropping, duplication, and asynchronous password guesswork, etc.
Coming to the challenges and future vision, the first thing here, if each edge or fog node authenticates the device individually, there will also be a need for extra delay, which is unacceptable in real-time services. This is the first challenge we are facing here. The next one, future 6G networks are expected to include time-sensitive services. The ability to satisfy these applications requested delays increases processing, which is beyond the capabilities of IoT devices. Next one, in this project, the safety of the cloud provider's consumer database was not addressed. As a result, future research will take into account the privacy concerns and put the authentication mechanism to the test in case of a database breach.
Finally, the conclusion. We introduced light edge and authentication protocol for IoT devices. In this structure, there were three secure sharing of information. First one is device and trust center. Second one is cloud provider and trust center. And the finally device and the cloud provider. If the trust center validated each of these communications, they were established. The collected findings revealed that the suggested protocol is secure against a variety of threats and simple and unique to implement. Thank you.
Thank you, Professor.